This is the University of Washington's Math 120 pre-calculus course. We're looking at the fifth question from the winter 2016 final exam. We have a perfectly circular lake with a radius of 26 miles. And we have someone named Nessie who is standing initially 30 miles east and 10 miles north of the center of the lake. And she's moving. She walks due west. And when she gets to the lake, she swims to the westernmost point of the lake. And the question asks us, when she is closest to the center of the lake, how far is she from her starting position? If you haven't already, go ahead and pause the video and see how you can do with making sense of this on your own. Okay, so let's start by drawing a picture. We have a lake. And we know initially that Nessie is 30 miles east and 10 miles north of the center. So here's our center. The lake is 26 miles in radius, so she's just a little farther east, and 10 miles north is maybe about here, is Nessie's starting position. And what does Nessie do? Nessie walks due west and then swims to the westernmost point of the lake, which is here. So here is Nessie's path. Let me put on hold thinking about the closest to the center bit and start just by explicitly modeling Nessie's path. In particular, I'm curious about Nessie's path from here to here. So let me impose some coordinates here. I'll say that the center is 0, 0. This westernmost point here looks like it should be negative 26, 0. And Nessie's initial position was 30, 10. And I'm not quite sure of the coordinates of this point here. What I do know is that the y coordinate there is 10. Maybe I'll switch to dots and reserve x for this variable here. So I can write an equation for the boundary of the lake, for the kind of circle that is the boundary of the lake. In particular, this circle is simply x squared plus y squared equals 26 squared. And if I'm looking for the x coordinate of this particular point here, I can simply plug in y equals 10 to this equation and solve for x. What I find then so I have in theory actually that x is plus or minus root 576, but based on the picture, I know that I'm not interested in this point over here. I'm interested in this one over here. So x is positive root 576. So what can I say about the path from here to here? Well, the numbers are a little bit ugly, but conceptually this isn't really so tricky. All I want to do in order to model the path from here to here is to notice that I'm talking about a linear path and I have 2 points. So my 2 points, I'll write them quite explicitly. I want a line that goes through these 2 points. Fortunately for us, the square root of 576 is 24, so we're really just trying to model the line that goes through these 2 points. So this isn't so bad. It's going to be something of the form y equals mx plus b. We just need the slope and the y-intercept. The slope, we have a rise of 10 from 0 to 10 and a run of 50 from negative 26 to 24. So the slope is 1/5. And for the y-intercept, we can simply plug in one of our points. We have b equals 26/5. So combining m and b, we have our equation for this path. This is Nessie's path through the lake. So we're interested in identifying this point here. Notice that this point will be on a perpendicular line from the center of the lake out. So we have an equation that models this. Let's write an equation that models this perpendicular. It's actually quite straightforward. The slope of the perpendicular will be the negative reciprocal of this slope, and the y-intercept will be 0 because this perpendicular goes through the origin by construction. So we can find this particular point simply by setting this line equal to this line. I'm going to multiply through by 5 to get rid of the fractions. So I find that x equals -1, and that means that y must equal 5. Let's make sure that this point actually is still on this line. It is. So the question simply asks us how far she is from her starting position when she is at this point. So this is quite simple. The distance between her starting position and this position is simply... So here we have our solution, and this is in miles.